Hello guys, so welcome to my today class. So in our previous class we were talking about indices. So in our today class we are going to be treating indices under two major problems. So it is that is under the one leading to simultaneous linear equation and the one leading to quadratic equation. So you can see that here we have a problem on the board. So let's simplify and see how we go about it. You see, if you solve for the value of x and y in the equation, so find the value of x and y in this equation. So what we're going to be doing here, we're going to apply some few ideas from indices, these laws, and then we can arrive at our answer. It's easy as that, easy peasy. So now, what do we do now? So you know, from our simultaneous linear equation, normally we have two equations, which are the equation 1 and equation 2. So for me, this is our equation 1 and this becomes our equation 2. So let's write it outside. So this becomes 2 to the power of x plus 2 to the power of y equals to 3. This is our equation 1. And from our equation 2, you can see very clearly that it's not looking like our equation 1. You know, for us to solve a simultaneous linear equation, the two equations must definitely look alike to be able to simplify it. Yeah, they must definitely look alike. So for our equation, so we're going to simplify it. So we're going to have like terms that we can replace them. I'm going to have kind of like terms so we can replace them. Yes. So for our equation 2 now, from the laws of indices, I'm going to break this one down. I'm going to break this one down. So this becomes 2 raised to the power of x times 2 raised to the power of 2 minus 3 raised to the power of y times 2 raised to the power of 1 equals to what? 8. So here is 9. Power of 8. So what's next now? Yes, our equation 1 is 2 raised to the power of x plus 2 raised to the power of y equals to 9. Our equation 2 is 2 raised to the power of x is already what broken down to give us this. So how can we then solve this simultaneously? Ordinarily, we know we cannot solve this using the idea of simultaneous equation. At this point, we can't eliminate, we can't substitute either. So what are we going to do? We're going to replace this value. I'm going to replace this value. So from here, I'm going to say let 2 raised to the power of x be equals to n, and let 3 raised to the power of y be equals to n. So if that's that, I'm going to have m plus n equals to 9 for equation 1, and then we're going to have 4n minus 3n equals to 8. This becomes our equation 2. So from here, you can use either elimination method, you can use either substitution method, and we can use Cramer's rule. But we can't use graphical method because graphical method is being done on graphs. Yes. So I'm going to use either elimination method or substitution method basically. For Cramer's rule, use the idea of matrices to solve Cramer's rule. So let's use, I think elimination method will be more easier. So let's make, for us to eliminate now, you know we have to eliminate either m or eliminate n. So for me, my choice is also your choice, either eliminate m or n. But for easy work, I will decide to eliminate m. This comes 3 times. Sorry, it's not clear. 3 times and what 1 times. What's happening here is that I use the coefficient of n here, multiply equation 2, and I use the coefficient of n in equation 2 to multiply equation 1. So that's it. So when you simplify now, this becomes 3n plus 3n equals to 3 times 9 equals 27. This becomes 4n minus 3n equals to 8. So for me, you can eliminate easily. So you eliminate 3 out, 3 goes out. 3n plus 1 becomes 7n. 27 plus 8 becomes 35. So what's up next now? Divide both sides by 7. It becomes n equals what? 5. So from this now we can get the value of n. Now what do we do to get our value of n now? So to the value of m into either equation 1 or our equation 2. So note this now. You can either use this equation to get the value of n, and you can also use this equation to get the value of n. Either way, you are still going to get the same value. So for me, I'm going to be using this one. So m m plus n equals 9. So let's put our value of let's put the value of m back to the equation. It becomes 5 plus n equals 9, and n9 is equal to the value of 4. And the equation says you should find the value of what x and y. Then you have to find the value of m and n. So what we also do now, we say let 2x be equals to m. So let 2 is the power of x be equals to m, and 3 is the power of y be equals to n. So we just put the value of m there and put the value of y there. So let me put inside. We copy and copy first. So now 2x, 2 is the power of x is equals to m, and our m is equals to what? 5. And for 3 now, this is 3y equals to n, and our n is equals to what? 4. Now how do we solve this? Now? What we do here is that we use the idea concerning the relationship between indices and logarithm. We use the idea concerning the relationship between indices and logarithm. Now this is in index form. What do we do to change from indices to what? Logarithm. Change the x now becomes log 2 is the power of what? 5. X becomes log 2 is the power of 5. Same thing applies for this other one. Y here becomes log 3 raised to the power of what? 4. Y here becomes log 3. Note that every logarithm is in the base of 10. Yes. So assuming we're having something like log 2. We are given value, say find the value of log 2. Note that this is same written as log 10 raised to the power of 2. Let's say find the value of log 3. This also considered written as log 10 raised to the power of what? 3. So what am I saying in essence is that we have to change the base for it to be suitable for us to work with. We have to change the base so that we can work with it. So I apply the idea of change of base. What happens here now? What base will be suitable for us to work with for 2 and 5? I told you our log is in the base of 10. So we're going to change it now. This becomes log 10 raised to the power of what? 5. And this becomes log 10 raised to the power of what? 2. Also for this side, this becomes y now equals to log 10 raised to the power of what? 4 all over log 10 raised to the power of 3. So let's punch our calculator to get the answer now. So log 5, change 0.6. Log 5, 0.699. If we approximate, log 5 gives us 0.69897. Then log 2 gives us 0.3010. Yes, so for y, log 4, 0.6020. Y log 3 becomes 0.47712. So let's divide. X will be divided by x becomes 0.698785. 2.32. And for our y, our answer becomes 0.606020 divided by 0.477. So it becomes 1.262 if I approximate. So now we've gotten our value for what's x and y. You can see it's very easy. We've gotten our value for what's x and y. So let's go to our next question. So for this now, this is one linked to simultaneous equation. Also, I'm going to solve the one linked to quadratic equation. So let's take that for that one first. So our second question goes like this. Okay, it says also we're still going to find another equation right here. So she calculate the value of, let me just have the question down. Calculate the values of x and y if 27 is the power of x all over x plus sorry, and just find the value of x and y if 27 raised to the power of x divided into 1 raised to the power of x plus 2y is equals to 9 and x plus 4y equals to 0. So now let's break it down. First thing now, when you say mathematical problem, the first thing that comes to mind is simplify for any mathematical topic, rather. It's the first thing that comes to mind is simplify. So now let's break this guy down because our equation 2 is already given out, so there's nothing to simplify in our equation 2. So that's for our equation 1 is 27 raised to the power of x. 81 raised to the power of x plus 2y equals 9. So this becomes 3 raised to the power of 3x. So expressed in the power of 3. So for our denominator, this becomes 3 raised to the power of 3 raised to the power gives us 81. I think 4. So let me just wash it. Yeah, 4 in brackets x plus 2y equals to 9. So let me tell you about this thing. So now what's up next now? Because multiply here. Since we have been equal to sign equals multiply. Then on this side we have been 3 to the power of 3x equals to 3 to the power of 4 in brackets x plus 2y times 2 to the power of 2. I'm expressing 9 in the words in the power of 3. Expressing 9 in the power of 3. So here this side becomes 3 to the power of 3x equals to multiplication of indices. We take a base and then we sum the powers. So 3 raised to 4 in brackets x plus 2y plus 2. So this one should write this one as this one should. So also having left says 3x equals to, so let's open the bracket, that is 4x plus 8y plus 2. Am I correct? Yes. So we take like terms. Correct like terms here. For me, we are going to be having, we'll cross the 4x to this side. We just cross both 4x and 8y to this side, so they become minus. So this becomes 3x minus 4x minus 8y equals to 2. So this becomes minus x minus 8y equals to 2. So this becomes our equation 2. Sorry, equation 1. This is our equation 1, and there the gives us our equation 2. So the x plus 4y equals to 0. This is our equation 2. So let's simplify now. So for me, I'm going to still be using elimination method. So here, it's easy. You can see that our x is already out. Negative x plus positive x. Note that as any ordinary number, at the front of any ordinary number, we are having a positive sign. If we are having an ordinary thing like this, note that at the front of it we are having a plus. We are having an ordinary thing, note that at the front of it we are having a plus. So note that at the front of any ordinary number, there is always a positive sign. So negative x plus positive x gives us what? 0. So that is out now. So minus 8 plus 4, minus 8y plus 4y gives us what? Minus 4y equals to 2. The variable side by minus 4, our y becomes minus 1 over 2. That is our y value. So let's look for our x value now. This one is much more easier. So for us to solve for our x value, what's happening to substitute our y value into any of the equation, either equation 1 or equation 2. So let's substitute into equation 1. Or rather, let me use equation 2 for this one. So x plus 4 minus 1 over 2 So s plus, so what's happening now? 2 here becomes 1, 2 here becomes 2. So 2 times negative 1 gives us what? Minus 2. So hence plus times minus is what? Minus. So this positive sign goes off, and then we're having what? Minus 2 equals to what? 0. I'm making sense. So I'll say, and I'm going to have s correct like saying this minus 2 equals over 3 equals to sign. Become positive, this becomes 0 plus 2. S sign equals to what? 2. So for my guess, I will say these 2 questions I've solved already. Can be able to guide you through any more questions you see concerning indices, the one leading to simultaneous equation. So that's it. So in case you see, if you have any question, please you can comment it below, or I'm going to write my WhatsApp number in the description, so you can maybe send me a DM. So now the one we are going to be handling now is going to be the one leading to quadratic equation. So it's going to be indices leading towards quadratic equation. Indices leading towards quadratic equation. Indices leading towards quadratic equation. Leading towards quadratic equation. So our first question there is 3 raised to the power of 2x minus 12. 3 raised to the power of x plus 27 equals to 0. So what I'm going to do here now is easy. Just as we did the last one, we're going to do this one too. It's very easy. The idea behind mathematics is just for you to get the concept. Let me just tell you one simple fact and truth. The idea behind mathematics is just for you to get the concept. If you can get the concept, I bet you can solve any mathematical problem. That is the idea behind mathematics. That's why sometimes it fits me to say, okay, mathematics is hard. No, it's never hard. So what I'm going to do is simplify. So this becomes 3x. We'll bring down the 2 halves. Know that if we are to open this bracket now, we multiply power, just as I did in my previous class. If we are to open this bracket now, we multiply the power. So if we are opening the bracket, it brings us back to 3 raised to the power of 2x. Please note that I just using this so I can be able to solve the equation and get the value of x. Minus 12 plus 27 equals to 0. So what I'm going to do here now is select 3 raised to x, because ordinarily we can't solve this quadratically. There is no way. So instead of you wasting your time and packing your mind on how you should go about it, you place the value of 3 raised to the power of x. You select 3 raised to the power of x be what? P. So this becomes p squared minus 12p plus 27 equals to 0. Now this brings us about our quadratic equation. Now how do we solve quadratic equation? You either use factorization method, you use the formula method, or you use the completing the square method. So let's see which one works out here. So I'm going to try the factorization method first. If it doesn't work, then we're going to use the completing the square method or the formula method. So what I'm going to do is multiply this. It becomes 27 p squared, and let's get this factor. Factor of 27 is 1, 3, 9. 9 can go then. I think than 27 itself. Yeah, I think 1, 3, 9, and 27. I don't think I'm going to 27. I'm sure this factor of 27 one. So I can clearly see the answer. Yeah. I can clearly see what we are going to add up here or subtract here to give us 12, and if we multiply they give us 27. And that's not that value than 3 and 9. If we add minus 3 minus 9, that's going to give us negative 12. And also if we multiply minus 3 and minus 9, it's going to give us positive 27. So factorization method can work here. So no need of using completing the square or the formula method. So let's just substitute p squared minus 3p minus 9p plus 27 equals 0. in bracket please. So what are we going to do here? Factorize. P out here, P minus 3 minus 9 here. This was P minus 3 equals 0. So we become P minus 9. That was P minus 3. Those are the two values of P now. P becomes what? 9 and 3. P becomes what? 9 and 3. But are we looking for P? No. We're looking for the value of what? X. So what I'm going to do now, we replace the value of P. Very easy. We replace the value of P where it's supposed to be. So this is going to raise the power of X equals to 9. This is going to raise the power of X equals to what? But express times the power of 3 becomes 3 raised to the power of what? 2. S now becomes what? 2. Let's try 3. So this is going to 3x 3 equals to what? 3. Now using the P value when it's 3. Yeah, we use the P value when it's 9. Now I think the P value when it's what? 3. So I am placing this 3 9 in place of P here. That I should choose earlier. So 3 raised to the power of 1 is so 3. So you know we're having the power of 1 here. So S 3 cancel out. S becomes 1. So the value of S9 is equals to 1 and what? 2. So that's it. You see, it's very easy. So I'm going to have our last question for today's class. Under the quadratic equation problem of indices, or the quadratic problem of what indices, we're going to have our last question for today's class. So our last question goes like this. It said, if 2x plus 2 minus 10 in bracket 3x plus 1 plus 9 equals to 0. So this is also another question under indices concerning what is quadratic problems. So what I'm going to do here, we also apply some balls of indices and then we see how it works out for us. So what I'm going to do here now is break them down, disarm them. So this becomes 3 to the power of 2x times 3 to the power of 2 minus 10 3 to the power of x times 3 to the power of 1. Next thing is plus 9 equals to 0. So after that, we can split this up to become 3 raised to the power of x. So we can break this down to give us this times 2 to the power of 2 minus 10 3 to the power of x times 2 to the power of 1 plus 9 equals 0. Also, we'll do the same thing we did for the last question, which we place the value of 3 to the power of x. Let's use q this time, or m. Let 3 to the power of x equals to m. Let's use m. So now, let's introduce m now as 3 to the power of x. So this becomes m squared times 3 squared. This is what I'm doing now. Minus 10 m times 3 to the power of 1 plus 9 equals to 0. Plus 9 equals to 0. So this becomes what? 9m squared minus, so m times 3 becomes 3m, multiplied by 10 becomes 13m plus 9 is equals to 0. Now, okay, I would have said that, okay, let's just solve this like this, but what happens is that it will be a stress, a very big, a whole lot of stress, because we have to multiply 9 times 10 is going to give us 81, and I'm going to find the factors of 81, so that's a lot of work to do. So what I'm going to do here, you observe something here that there's a common factor of 9, 30 and 9 that's going to break all of them down. Yes, that's going to reduce them. So the factor of, we can multiply, we divide all through by what? 3 to break them down. Divide all through by what? 3. Divide all through by 3. So 9 into 3 becomes what? 3m squared. To avoid the stress, minus what? 10m plus 3. Also gives us 0. So we can work with this. So now, this same thing we did there now becomes 9m squared. What are the factors here? We have 1, 3, and then 9 itself. So what are we going to do? We are going to look for two numbers that when we add them or subtract them are going to give us negative 10. And also when we multiply them, it's going to give us plus 3. Now look. We are having 3 factors which are 1 and 2, 1, 3 and 9. So if you look at this carefully, there is no two number that will multiply that will give us positive 3. But if you look at it now, there are two numbers here. If we should subtract them or add them, it will give us minus 10. But still, the two must always be in accordance. You can't go for one and leave the other. Yes. So since factorization won't work here, we use formula method. Now be more short and quick. We use formula method, which is minus b plus minus square root of b squared minus 4ac over 2a. So our a now is equals to plus 3, our b now is equals to minus 10, and our c now is equals to 3. So substitute now, our b is negative 10, substitute it here, becomes 10 plus minus square root of what b squared. B is negative 10, so it becomes 100 minus 4 times a, that is a is positive 3. 4 times 3 times 3, that becomes 4 times 9 all over 2a. Looking for n here. All about 2a, that is 2 times 3, that becomes 6. So our m now is equals to 10 plus minus square root of 100 minus 4 times 9. 4 times 9 is 36 all over 6. So our m now equals to 10 plus minus, I think this will give us 64 all over 6. So now m now equals to 10 plus minus square root of 64 is 8 all over 6. So split this up. We split this up now. We're having a positive sign or having a negative sign. So work it from both of them. So this becomes m equals to 10 plus 8 all over 6. 10 minus 8 all over 6. So m becomes 10 plus 8 gives us 18. 18 divided by 6 gives us 3. 10 minus 8 gives us 2. Yeah. 2 into gives us 2 into 6 gives us 1 over 3. So these are the value of m. Oh, these are the value of m. So what did we replace earlier now? We said that let 3x be equals to what? M. That was our earlier replacement. So substitute the value of 3. This becomes 3 to the power of x equals to 3. Now using the value of m when m was 3. So h strike out m becomes what? 1. Or we can also use this one. Guys, 3 to the power of x equals to what? 1 over 3. But I know that 1 over 3 can still be written as 3 to the power of negative 1. So this becomes 3 to the power of x equals to 3 to the power of negative 1. And this becomes minus 1. So our value of x becomes 1 over negative 10. Thank you for your time and enjoy the rest of your day.